Hi, I'm Shanika Center. I'm the Virtual Content Specialist for Middle School Science for English Language Learners and Multilingual Learners. This is the last video for the week of May 17th, and it's going to be on carbon emissions. This is a student-facing video that helps them calculate the per capita emission of carbon dioxide with their partner. So this video, we're going to learn a little bit about what carbon emissions are and why it's important to understand the average emissions. Hi, I'm Shanika Center. I'm the Virtual Content Specialist for Middle School Science for English Language Learners and Multilingual Learners. In today's video, we are going to learn about carbon emissions and why it's important to know how much carbon each of us are emitting. This lesson is for day 5, unit 5, where we're going to calculate the average emissions. Before we get started, let's review some vocabulary words. So carbon dioxide is one of the gases in the atmosphere. It's really important for plants during the process of photosynthesis. When we breathe out, we exhale carbon dioxide. However, too much carbon dioxide is not good for our climate. So emissions are just gas or things that are released. In this case, we're going to be talking about carbon dioxide and other gases. Carbon dioxide emissions, it's the carbon dioxide that is released into the atmosphere. And there are a variety of ways that carbon dioxide is emitted into the atmosphere. Per capita just means per person. So when we're calculating the per capita carbon dioxide emission rate, we're looking at how much each person is emitting, how much carbon dioxide each person is putting into the atmosphere. This example is 1 cookie per capita, so 1 cookie per person. One of the main questions that you have to be able to answer to understand the importance of this lesson is, what do carbon emissions have to do with climate change? So to help us get a better understanding of this answer, we're going to watch a quick video.
Back in the 18th century, people started burning coal to power a new invention, steam engines. But here's something curious. Ever since steam engines were widely used, starting in about 1850, the amount of carbon dioxide in the atmosphere began to climb. Today it stands at 392 parts per million. Parts per million is a special measurement scientists use. 392 is way more carbon dioxide than we've had for many thousands of years, and the number continues to rise. So where does the extra carbon dioxide come from? You might say it comes from our success. And steam engines were just the start. It comes from our bustling cities and towns, filled with things like cars, planes, factories, office buildings, homes, computers, TVs, air conditioners, and refrigerators. All those inventions were good, and we've accomplished some amazing things because of them. But they all require one thing: energy, lots of energy. And it's our thirst for energy that has some unintended consequences for the planet. Where does energy come from? Well, we get most of it from burning things like coal, oil, and natural gas. These are called fossil fuels because they were formed deep in the ground over millions of years by ancient decaying organisms, or fossils. Chances are, most of the things that you do that take energy in a given day are powered by burning coal in a power plant. And of course, you burn gasoline, which comes from oil, when you ride in a car. Meanwhile, many homes and buildings are heated by natural gas. Fossil fuels are full of energy, and they've been useful to us. But there's a problem. Burning them releases carbon dioxide into the atmosphere. In 2009, each person in the United States used enough fossil fuel energy to release an average of 17 tons of carbon dioxide. That's about the equivalent of 4 African elephants. Over time, all of that carbon dioxide really starts to add up. And because of the thickening blanket that causes the greenhouse effect, the more carbon dioxide there is, the higher Earth's average temperature goes. Scientists and the governments of many nations now agree that we're releasing too much carbon dioxide, and to prevent the worst effects of rapid climate change, we're going to have to reduce that 392 parts per million number to about 350. Fortunately, by making good choices now, we can tackle the problem of too much carbon dioxide. And in case you didn't know, you can be part of the solution too.
Now that we're done watching the video, it's time to do some math. We're going to look at which country or region emits the most carbon, and thus which country or region is contributing the most to climate change. So to do that, we are going to use the chart provided for you in your notes. There's going to be 3 slides that have these charts on them, and you're going to fill out these 2 bottom boxes that shows the math and then the final answer. So I'm going to show you how to do that using the calculator on your phone. So you're going to go to the calculator and then you're going to type in the numbers. So I'm going to do the green box first. So 1,000, hopefully you can see 1,200, which is the total CO2 emission, divided by the number of people, the population, which is 1,100, and then I'm going to press equal. So then I get my answer, which is 1.090, blah, 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 blah. I'm going to round up, and that's how I got my answer of 1.1 tons. So you are going to complete the rest of the per capita emissions in your notes. When you're finished, you're going to answer the rest of the questions in your notes.